Okay, so my name is Bilal, and today we'll be solving Cambridge IGCSE Mathematics 0580 P2 Chapter 7 Graphs. Now, before starting, I would like to make an announcement that please do like, share, and subscribe our channel. We'll start with question 1, which is given as the diagram shows information about the first 100 seconds of a car journey. Right? So, first 100 seconds of a car journey is given. Calculate the acceleration during the first 20 seconds of the journey. Right? So we need to calculate the acceleration between these 2 points, right? So speed time graph is given. You can calculate the gradient of speed time graph. Gradient of speed time graph gives you acceleration, right? So we'll be calculating the gradient. We have this as 0, 0, and this would be 20 and 16, right? So this would be 16 over 20. That would be 4 over 5, right? Moving on, we have question number 2. Work out the total distance traveled by the car in the 100 seconds, right? So we need to calculate the distance the car has traveled in 100 seconds, right? So let's just break this down. So this would be a triangle over here. This would be a trapezium, and this would be a rectangle. We are adding all the three areas to get our final distance, right? The area under the line in speed time graph gives you distance. All right, so please do keep these things in mind, this one and this one, right? So this is the first thing, and this is the second thing, right? So we need to calculate the area. First we have triangle. A triangle's area is 1 upon 2 base into height. So our base is basically 20 and our height is 16. So this would be 20 multiplied by 16. Then we have our trapezium, which is 1 over 2 sum of parallel sides. These are the two parallel sides. So this is 12 and this is 16. So this would be 12 plus 16. And our height is basically 30. And we have 1 over 2. Sorry, we have a rectangle over here. So this is basically 50 and this is 12. Length is 12. Right? So 50 multiplied by 12. We cancel it out. This will be cancelled again. So this would be 160 plus. I'm sorry. And then 18 into 15 would be. Let's use the calculator over here. That would be, I guess, 270 or so. 18. Let's just verify it. 18 into 15, let's say basically 18 into 15, so this would be 270, right? We have 270. Then here we have 12 into 5 is 60, and then 600. We add these all up to get our answer as this would be how to clear it. This is basically 600 plus 270 plus 160. This is, I think we made a mistake over here. So this is basically 20 and we have our height as 30, right? Yeah, we have our height as 30. We have this as 16 and this as 12. Oh, sorry, this isn't 18, this is 28, right? So we have to change it. This would be 28 multiplied by 15. So this is 420. Now we add these things up. This would be 1020, and this would be 1180, right? So this is the answer. Now we have question number 2. The diagram shows a speed time graph for the journey of a car. Please do remember these things, this one and then this one, right? We'll be using this in the later parts of the video. Calculate the total distance traveled. For the total distance traveled, we need the area under the line, right? Whole area is to be calculated, right? So this is basically a trapezium. That would be 1 over 2. We have our height as 12.5. We have sum of parallel sides. This is 280. And this is basically 220 minus 20. That would be 200. Right? So we have this. We get it as 12.5 multiplied by this would be 480. This would be cancelled out. This would be 240. We calculate this. 240 multiplied by 12.5. This would be 3000, right? So we get our answer as 3000. Moving on to question number 3, we have Petra begins the journey in her car. She accelerates from rest at a constant rate of 0.4 meters per second for 30 seconds. She then accelerates at a constant speed for 40 seconds. On the grid, draw the speed time graph for the first 70 seconds, right? So for first 30 seconds, it accelerates for 0.4 meters per second. Let's just calculate how much speed she attains at the end of 30 seconds, right? Since she starts from the rest, right? So we have speed is equals to we have our acceleration as v minus u over t, whereas v is the final velocity and u is the initial velocity, right? So we have our acceleration as 0.4, we have our final velocity to be calculated, we have our initial velocity as 0, and we have our time as 30 seconds, right? So this would be multiplied, we get our answer as this would be 4 into 3, 12, right? So we have 12. So at 30 we have 12. This would be right here, and we'll draw a line over here. Just use the scale. This would be it. Now we have she then travels at a constant speed. So for a constant speed, it will be a straight graph, horizontal line, right? Like this. Now moving on to question number 4, we have the diagram shows a speed time graph. Calculate the total distance traveled. Again, we have to calculate the area over here. So for area, we need the area of trapezium. We have 1 over 2. We have our height as 12, and this is basically 7, and this whole is 15. So this is 7 plus 15. This would be 23. This would be cancelled out. We need to calculate 6 multiplied by 23. Just use our calculator. 23 multiplied by 6 is 138. Or did we make a mistake over here? This is 22. Making some silly mistakes over here. I think I need a break. This is 22 multiplied by 6. So we get 132. Right? Now we have our question 5 as calculate the distance between the two stations. The speed time graph shows information about the journey of a tram between two stations. So for distance, we need area. Again, we'll be using the area of trapezium again. So this would be 1 over 2 multiplied by the total sum of parallel sides. So this is basically 90, and this whole is 130. So this would be 90 plus 130. And we have our height as 20, so let's just cancel it out. So this would be 10, and then we get 220 multiplied by 10 would be 2200, right? Now in part B, we have calculated the average speed of the tram for whole journey. We need the average speed of the whole journey, right? So average speed is given as total distance over total time, right? So we have our total distance is 2200. The time it took was 130 seconds. This would be divided, and then we get our answer as 16.9. You can use the calculator over here. 220 divided by 13. Yeah, 16.92 or 16.9, right? Now moving on to question number 6, we have the diagram shows information about the first 8 seconds of a car journey. Right, the car travels with a constant acceleration reaching a speed of v meters per second after 6 seconds. The car then travels at a constant speed of v meters per second for a further 2 seconds. The diagram is shown over here. Right, the car travels a total distance of 150 meters. Now it is given that it travels for a 150 meters. So is it a trapezium? 1, 2, 3 and then 4. Yes, it is a trapezium. It is a right trapezium, right? So we have this parallel side, right? So we'll be using the area of trapezium formula. So this is 1 over 2, and we have the distance between these two as 2, and then this hole is 8, and we have our height as v, right? We have our distance as 150. This 2 plus 8 would be 10, and this would be cancelled out to get our 5. This 5 would be divided, so we get our v as 150 divided by 5. This is basically equals to 30, right? So we have an answer as 30. Now moving on to question number 7. We have the diagram shows the speed time graph for 60 seconds of a car journey, change 90 kilometers per hour to meters per second, right? So this 90 is given in kilometers per hour. For it to go from kilometers to meter, a 1 kilometer is equals to 1000 meters. A kilo means 1000, right? So we need to multiply it by 1000 first, and then we need to calculate per hour to per second. So we need to divide it by 3600. These two would be cancelled out. This would be 5 and this would be 18, and this would be cancelled out. So this would be 5 multiplied by 5, or make a mistake over here, or am I right? Yeah, I'm right. 25. Find the deceleration of the car in meters per second. It needs this deceleration, right? So we have in meters, meters per second square, right? We have 25 meters per second as this, right? So in 20 seconds it decelerated from 25 to 0 in 20 seconds. So this would be 25 minus 0 on 20, and this would be 25 over 20, that would be 1.25. Since it's already a deceleration, we will not be putting a negative over here, right? Find the distance traveled in meters in the 60 seconds, right? We need to calculate the distance. So for that we need the area, right? Please make sure to keep it in meters to keep the speed in meters per second, right? So I will be using again the trapezium's formula. We have the height as 25, we have the whole base as 60 and 40, right? So this would be cancelled out. This would be 50 multiplied by 25, 5 25s are 125, and then 0. So this would be 1250, right? We have our question number 8, which is given as a diagram shows the speed time graph for the first t seconds of a car journey. Find the acceleration during the first 10 seconds. It needs the acceleration during the first 10 seconds, right? So it has a speed, it gained a speed of 12 meters per second, and in the 10 seconds, right? So this would be 12 over 10 simply. This would be 1.2, right? Since it's given it's meters per second and this is seconds again. The total distance traveled during the time t seconds is 480 meters. Find the value of t, right? So we have a distance as 480 meters and we need to calculate the value of t. Again, we'll be using the area of trapezium over here to ease our task. So this would be 1 over 2. We have our height as 12. We have our sum of parallel sides would be t and t minus 10, right? This is whole t and this is basically t minus 10, right? So this would be 6 and we have our distance as 480. this 6 would be divided, and this would be 8t. We have 2t minus 10. This 10 would go over there, so this would be 90 over 2 as t, and we get our answer as 45. Right? Now moving on to question number 9, we have diagram shows information about the final 70 seconds of a car journey. Find the deceleration of the car between 60 and 70 seconds. Right? Final 70 seconds are given, and it needs a deceleration of the car between 60 and 70 seconds. Right? So this is basically required. This gradient is required. Acceleration, we need the gradient. Right? So in 10 seconds, it decelerated from 20 to 0, right? 20 minus 0. So this would be 2 meters per second square, right? Now find the distance traveled by the car during the first 70 seconds. Let's just calculate the area. For distance, we have the area, right? So we'll be using again the trapezium, right? Area of trapezium, which is given as 1 over 2, and we have this till this, we have 60 and 70, right? So this would be 60 plus 70. We have our height as 20. This is basically our height. This is the height of the trapezium, right? We have these two as sum of parallel sides. This is 60 and this is 70, right? So this would be cancelled out, and we get our answer as 130, and 130 and multiplied by 10 would be 1300, right? Moving on to question number 10, we have a car travels at 20 meters per second for 15 seconds before it comes to rest by decelerating at 2.5 meters per second. Find the total distance traveled. First of all, we need to calculate this t, right? Here we are given the deceleration, right? So this would be deceleration is negative 2.5. We need the final t, right? So this would be t minus 15. And we have our velocity as 20, or the speed as 20, right? This is basically 15 comma 20, and this is t comma 0, right? So we have 20 minus 0, and then 15 minus t. Sorry, this would be 15 minus t, right? Okay, so this would be multiplied by this, or you can simply divide 20 by 2.5. So this would be 20 divided by 2.5. We get our answer as 8 as 15 minus t. Our t would be 15 minus 8, so we get our t as 7. So this would be 7. 7 would be added, I guess. This would be 7. 15 plus 7 would be 22, right? Okay, so we have t as 7. So this would be t wouldn't be 7, t would be 22. 15 plus 7, right? Because it's added in 15. Okay, so we have our this value 22. We can simply use the area of trapezium formula, which is given as 15 plus 22. Then we'll be multiplying by height. This would be this, so this would be 10, and 15 plus 22 is 37 or 38, 37, 370. So this would be 370, right? Now moving on, we have question number 11 as this. Did we make some mistake over here? No, I think we didn't. Okay, so we have our question number 11, which is given as something like this. We have the speed time graph shows information about a train journey. By drawing a suitable tangent of the graph, estimate the gradient of the curve at t is equals to 24. Right? We need the gradient of the curve at t is equals to 24. Right? So here we need a scale. t is equals to, this is 22.5, this would be 23, this would be 24, right? So this would be it, this would be the point, right? So let's just move our scale over here, so it looks something like this, right? So we have our this point as 26, 27, 27.5, and then 27.75. This would be 27.75 to be accurate, right? 0, 2, 27.75, and this is basically what, 24 as our x. Sorry, did we make a mistake? I guess we have 27.75 over here and y as 0, and we'll have 24 as x over here, and our y would be 1.5, this is 1.5, this is 1.2, this is 1.4, and this is something closer to 1.5. Just take this as 1.5, right? So we have 1.5 divided by 3.75, right? So this would be 1.5 divided by 3.75. We get our answer as 0.4, around something, 0.4, negative 0.4. This would be negative 0.4, right? So this is negative 0.4, right? So this is 1.5 minus 0 and 24 minus 27.75, right? So we get our answer in negative. What does this gradient represent, right? This gradient represents deceleration, basically. Negative gradient in speed time graph means deceleration, basically. Work out the distance traveled by the train when it is traveling at a constant speed, right? So for a constant speed, let's just remove this. This is the constant speed, right? This is the constant speed, I guess. I'm making it correct, I hope. This is 1, this is 20, this is 22, and this is 5. So this would be 17 in this length, and this is 4, so this would be 17 multiplied by 4. So we get our answer as 68, right? Moving on to question number 12. We have speed time graph is given for 70 seconds of a car journey. Calculate the deceleration of the car during the first 20 seconds, right? So we have this as 0, 16, and this as 20, 10, right? So we're subtracting these two and then these two in the denominator. So this would be 16 minus 10, this would be 0 minus 20, so this would be 6 upon 20. This would be cancelled out, so this would be 3 over 10 or 0.3. In the deceleration, we will not be using the negative sign since it's already written that it's a deceleration, right? Now we need to calculate the total distance traveled by the car during the 70 seconds. We need to calculate the area under the graph, area under the line. So this is basically a trapezium and this is basically a rectangle, right? A rectangle has length of 10 and this breadth of 50. This is 70 and this is 20, so this would be 70 minus 20, 50, and this is 10, right? So we have 10 multiplied by 50, which is 500, which would be added in area of trapezium, that is 1 over 2. This is the height, which is 20. We have sum of parallel sides, this is 12, this is 10, and this is 16, right? So that would be 10 plus 16. This would be cancelled out, so we get 26 and then 260. This would be added and we get our final answer as 760, right? Moving on to question number 13. We have the diagram shows the speed time graph for the 90 seconds journey, calculate the total distance during the 90 seconds journey, right? So first let's break this down. This would be a trapezium, this would be a trapezium, and this would be a rectangle again, right? We'll be adding these two to get our final distance, total distance, right? Since it's an area. A speed time graph gives a speed time graph's area gives us the total distance, right? So for the trapezium, let's just say A of trapezium plus area of square, right? So for the area of trapezium, we have 1 over 2. We have this height as 30. We have the sum of parallel sides. This is 6 and this is 12. So this would be 6 plus 12. We have the area of square as, we have our length as 12. And we have our breadth as 90 minus 30, basically 60, right? So this is 720. 12 multiplied by 6 is 72, and then adding the 0 would be easier task. So this would be 2, and this is 18, and this would be cancelled out to get 18 divided by 2 is 9. 30 multiplied by 9 is 270. This would be added, so this would be 990, I guess, right? So this is our final answer. Moving on to question number 14. The diagram shows the speed time graph of a train journey between two stations. Find the acceleration of the train during the first 40 seconds. It needs a gradient. Acceleration means gradient, right? So for that, we have 12 over 40 because it attained a speed of 12 and it traveled for 40 seconds, right? So we can cancel this out. This would be 6 and 20, and this would be 3 over 10, right? So this would be 0.3. Now calculate the distance between the two stations. For calculating the distance, we need to take the area under the graph, right? So we'll be using the area of trapezium. Over here, we have 1 over 2. We have our height as 12. This is basically our height. And we have sum of parallel sides. This is 300. And this is 250 minus 40. That is 210. This would be cancelled out. This would be 510 multiplied by 6. This would be 0. This would be 6. 6 5s are 30. So this would be 3060. Right? Moving on to question number 15. We have two bodies that would be traveling. The diagram shows the speed time graph for 100 seconds of the journey of a car and a motorbike. Find the deceleration of the car between 60 and 100 seconds, right? So it needs a deceleration of this, right? So this is 60 comma 18, and we have this as 100 comma 6, right? So this is basically 18 minus 6 over 60 minus 100, right? So this would be 12 over 40 again, and this would be cancelled out by 4, so this would be 3 over 10, so this would be 0.3 at last. Because it's a deceleration, we will not be including a negative sign over here, right? Otherwise it would have been there. Calculate how much farther the car traveled than the motor's bike during the first 100 seconds, right? So we calculate the area of car, then we subtract the area of motorbike from it to know how far they have traveled, right? How far the car has traveled, right? For the area of car, we'll be using trapezium, I guess, or no? A trapezium and this is the trapezium and this is a I guess rectangle. So for area of car, we have 1 over 2. Area of trapezium would be, we have this height as 40, and we have sum of parallel sides as 18 and 6. This would be 18 plus 6, and this rectangle would be added. This is 18 and this is 60. This would be 18 multiplied by 60, right? And the area of motorbike is basically a rectangle, right, which is 12 multiplied by 100, which is 1200, right? Let's just calculate this. So this would be 8 6 are 48, and this would be 1080, and this would be cancelled out. So this would be 20, and this is 24. 24 multiplied by 2 is 48, and this would be 480, right? So we can add these two. We'll get our answer as 1560, I guess. 1560. This would be subtracted by 1200 to get our final answer as 360, right? So this was all from my side. Thank you for watching till the end, and please do like, share and subscribe our channel. Thank you so much.